Okay, so this is the functions test from x squared first, outer, inner, last. So x squared minus 14x plus 49. I'm not going to go through how many marks each one is, just the content. Okay, in this case I need to factorize the top and the bottom, factorize as much as possible. The numerator can't be factorized, but the denominator can. I've got a common factor of 6 and a common factor of a. Then I put my brackets. Here I need an a so that I can end up with 6a squared, and here I need a 7. Now I can cancel an entire numerator with an entire denominator, but you need to be very, very careful. Some of you may have written the answer as 6a. This is actually, if you think about it, if you cancel something like 4 twelfths, for example, when you cancel, you divide top and bottom by 4, and you end up with 1/3. You don't end up with 3. Same here, you're dividing by a plus 7, so it's 1 and 6a. So the answer is 1 over 6a. Okay? All right. I'm asked to, here I'm subtracting a number and a fraction, so I need to get my common denominator. The invisible denominator there is 1. I'm going to make both denominators x minus 2. So I need to multiply 1 by x minus 2, and I need to do the same to the top, 3 brackets x minus 2. This one stays the same. Now that my denominators are the same, I can put those together, and I can multiply that out. So 3x minus 6 minus x, and simplifies to 2x minus 6 over x minus 2. I can't cancel that anymore. Okay. All right. With the other class, people did this in 2 different ways. Some people multiplied to get rid of the 4 and the 6, and some people put all the fractions on one side. I'm going to do first multiplying by 4 and by getting rid of the denominators. Okay? So, because you've got an equal sign, you're allowed to do the same to the left and the right. Okay? And it will keep the equation the same. Now, if I multiply by 4, if I multiply everything by 4, can you all see how that over 4 will disappear? Yeah? If I multiply everything by 6, then that 6 will disappear. Yeah. Is there something I can multiply everything through by that will get rid of both of them? 12. 24 would have worked as well, but would have just been bigger. 12 is easier. So I'm going to multiply everything through by 12. When I multiply this by 12, the 12 and the 4 becomes a 3. When I multiply this by 12, the 12 and the 6 become x over, 2x. Yeah, so I'm multiplying this by 12, and this by 12, plus 60. This is now a linear equation, so I'm just going to multiply out the brackets, and I'm going to collect all my x's on one side. So subtract 2x gives me x, and add 3 gives me 63. Any questions? It's going to be on. Okay. All right. The other class had a lot of issues with these 2 questions. I think a lot of people are still unsure about what a function actually is. So just before I answer the question, I'm just going to remind you the different representations you can have for a function. You can have a function where they don't tell you what the rule is, because there might not even be a rule, but they just tell you some of they tell you the inputs and the outputs. So I might have a rule that goes 1, 5, 1, 7, 2, 9, for example. That's a relation because I've got inputs and they're giving me outputs. Now would this be a function? No, it wouldn't be a function, because you're not allowed to have one input giving you 2 possible outputs. Or if you think about it as sets of numbers, if you've got 1 and 2 here, and 5, 7, and 9, you're not allowed to have the 1 going to the 5 and to the 7. Now this is one type of function, and the domain of the range would be just those numbers and those numbers. The other way is when you've got an actual rule, a mathematical rule, like 7x squared plus 5x. In this case, again, you think, what could be the possible inputs? What could be the possible outputs? Okay, so in this question, yes, it is a function because there is no, different ways of saying it, you can say there's no input that has two outputs. There's no x value repeated for different y values. Any other way of saying it? There's only one output for each input is correct. This is allowed. You're allowed to have two inputs giving you the same output. That's okay. So explain it in some way. The domain are the numbers, the input numbers. So -1, 1, 2, and 9. And the range is the output numbers 4, 5, and -3. Why it's a function? So why it's a function? Because how did you say it, Jenny? You had a good. There's only one output for each input. That's right. There is only one output for each input. Okay, you're not allowed to have 2 or 3 inputs. Now on the next one, this doesn't happen. You've actually got examples of input. For example, this input, the input 1, has got 2 outputs. It's got the output 3 and -1. This one as well has got 2 outputs. This one has got 2 outputs. Another way of saying it is it doesn't pass the vertical line test because I can draw a vertical line which crosses the function twice. So no, you can say vertical line test crosses the function twice. You could also give some examples. You could say output of x has got 2 possible y values. Right, the domain and range, a lot of people are struggling to get their head around this. The domain and range are the possible inputs and the outputs. So the inputs, and if you think about this is the x-axis, it's got an infinite set of numbers, numbers. And the question is, does every single one of those inputs have a matching, or 2, at least one matching output? And hopefully you can realize that all of these x values have a y output. They have a y output, they have a y output, they have a y output. These do not. Okay, so only the x values that are bigger than -3, that are real numbers, and bigger than -3, greater than or equal to -3, have got an output. Okay? Whereas the y values, the question is, are there any y values that can't be used as outputs? And there are none. We assume that this carries on to infinity in that direction, and this carries on to infinity in that direction. So I'm never going to come across a y value that doesn't cross the function, doesn't have a matching y value. So the range is just the real numbers. Okay. Okay. I'll just freeze it there. Okay, so this time we've got 2 different functions, r and t. And remember, the basic thing is that you understand what this expression means. This isn't r times x. It's to apply r to this, which is in the bracket. In this function, I add 2 and I square root. In this function, I square, I double, I subtract 3. So I'm going to take x, I'm going to apply r to it, and then I'm going to apply t to it. So I start with x, I'm going to apply r to it, this is what I get, and then I'm going to apply t to it. T says take whatever's in the bracket, square it, double it, and subtract 3. What happens with this square and the square root? They cancel each other out, so it becomes 2 brackets x plus 2 minus 3. You can only cancel out because it's one big square and square root. Okay, if you had this, you couldn't just cancel those out. Okay, but because it's just one square root, you can. No, there's nothing that you couldn't simplify that any further. You can't merge or split an addition. They're 2 completely different things. Right, so So if you had that, you'd have to FOIL. Yeah, you'd have to do root 2 plus root 7 times root 2 plus root 7. Yeah. Okay, and then multiply out. So 2x plus 4 minus 3 gives you 2x plus 1. Any questions? Right, be really clear on what you found. You found that these two composed together is that. The next one is the inverse of x. So the inverse of r, sorry. So remember, we start by stating the function as it is. So y equals square root of x plus 2. The order really matters here. At the moment, what r does is it says add 2 and then square root. Okay, so I'm going to do that process in reverse. So we write it as it is originally, then we swap the x and the y axis because we don't want to get from x to y, we want to get from y to x. What do I undo first? The square root by squaring both sides. And then I subtract 2. Minus 2 equals y. So the answer is, this is the question, r minus 1 of x equals x squared minus 2. Right. Now hopefully you realize there's a link between B and C. B says figure out how to do the inverse. C says apply that inverse to the number 9. Okay? So I need to apply the inverse rule to the number 9. So I'm going to do 9 squared minus 2, 81 minus 2, which is 79. And if you just check it, if I plug the number 79 into here now, 79 add 2 is 81, square root of 81 is 9, I get 9 back. Okay, then it says determine the value of x where this is equal to x. Now t of x is 2x squared minus 3 equal x. That's a quadratic equation. I'm not going to go through in detail how to solve it. Factorize 2x and x. I need a minus 3, so it's going to be 3 and 1 or 1 and 3. 3 and 1. Is that going to work? Negative 1 and positive 3. You're right. So the answer now, that will work. Because I'm going to get plus 3x. No, it was right the other way around. Okay, let's just double check. When we do FOIL, I'm going to get 2x squared plus 2x minus 3x, which is what I want, and minus 3. So either this is 0, which rearranges to 3 over 2, or this is 0, which rearranges to minus 1. Any questions? Yeah, I'm going to leave it then. Turn the page. Yep. I think you could probably do that in your head, yeah. Okay, number 4. So we're going to find, we've got 2 points. You can draw them if you want to, but I think it's a little bit of a waste of time. The first thing I'm going to find is a gradient. I'm going to use the formula. I'm going to use the formula which says y1 minus y2 over x1 minus x2. It doesn't matter which way around as long as you're consistent. Okay, so I'm going to do 2 minus 10. Be really careful with your signs on these. And then 2 minus 2, which is 2 plus 10 and 2 plus 2, 12 over 4, which is 3. So I'm trying to build, my aim is to build the equation y equals mx plus b. I know the value of m now. It's 3. And I know that this point is on the line. So this point has got to follow the rule. So if x is 2, I've got to get an answer of 2. So I'm going to substitute that point there. So 3 times 2. See how I'm learning to do the dot? Plus b, which becomes 2 equals 6 plus b. So b is minus 4. So the formula is y equals 3x minus 4. And you should be able to plug in one of these -2 and you should get an answer of -10, so you can actually check if you've done it right. Okay? Concerned that you have lots of blanks there. Okay. For this one, you needed to, first of all, make y the subject. So we've got 3x minus 4y equals 8. I'm going to make y the subject. So minus 4y equals minus 3x plus 8. And then divide everything by minus 4. 3/4 of x minus 2. And then the gradient is this. And we're told that this gradient, well, they have to have the same gradient because they're parallel. So 3/4 equals k minus 5. Make k the subject by adding 5. K is 5 3/4, or 23/4. Yeah. Super. Okay. Doing well. Okay. Right. Moving on. Last question. Last question. So, the only difference with this page is it's applied questions. So, it's not just y and x, it's h and t. If you look on the axes, it's h and t. And things actually mean something. Now, the formula you have normally is y equals ax squared plus bx plus c. So we need to make sure we identify what a, b, and c are for this particular one. A is always the coefficient of x squared, or in this case, t squared. So a is minus 3. B is always the coefficient of x, or in this case, t. So b is 36. What's the value of c? 0. Okay, so equation of the axis of symmetry, that's on my formula sheet. The formula says is x equals minus b over 2a. It doesn't matter whether you attach that minus to the b or to the whole fraction, but don't attach it to the b and to the 2a. Don't put two minuses there. So b is, in this case, right, in this particular case, we're not going to use x, we're going to use t. B is 36, so minus 36 over 2a. 2a is minus 3, so 2 times negative 3 becomes minus 36 over negative 6, which is 6. So the equation, and make it really clear, is t equals 6. Now, you don't have to do this right away, but I'm going to go down and already put that on my graph. T equals 6 is this one here. That's my axis of symmetry. Now, look at the value of a. Is it a happy parabola or a sad parabola? It's a sad. So it's a negative parabola, if you like. So it's going to have a maximum. And I'm looking for that maximum. All right? I know two things about that maximum. That vertex, I know it's on the line 36 minus 3t squared, and it's also on the line t equals 6. So I already know one of its coordinates. One of its coordinates is 6. So I'm going to sub t equals 6 into the equation h equals 36t minus 3t squared. Just substituting it. So 36 times 6 minus 3 times 6 squared. Careful with order of operation. That means you've got to square first. So 36 times 6 minus 3 times 36. I'm not going to do it now, but if you do the maths for that, you get 108. So the coordinates for the vertex are 6, 108. I'm going to go down and plot that right away. And it's there. Okay. So to find the t-intercepts, I need to get it into intercept form. So I need to factorize this. Now, when you've got two terms, you're never going to have two pairs of brackets. Okay, it's always going to be just one pair of brackets. What's going to go on the outside? What's the common factor? 3t. And then 12 minus t, correct. And we want to know the t-intercepts, which are going to be somewhere on this axis. So we know that the t-intercept, or the x-intercept, if you like, is when y is 0. So when this equals 0. And that happens either when t is 0 or when 12 minus t is 0. going to mark it on the graph. T is 0, T is 12. Okay, and now we can actually draw it. So it goes up and then down. And now we've actually got a situation here. It's a cannonball being fired up. So what's the maximum height? Call it out. 108 meters. If you don't put the meters, it's meaningless. So make sure you do. When will the ball first reach a height of 81 meters? You could do it from the graph. You could do an estimate from the graph. It's going to be around about there. But it does say you must show your calculations. So you should do it algebraically as well. So this is the formula for the height of the ball. And the question is, when is this going to be equal to 81? So quadratic equation, I'm going to move everything to the right-hand side. So 3t squared minus 36t plus 81. Before you go ahead and put everything into brackets, what do you notice? 3, 36, 81. They're all divisible by 3, so I'm going to put the 3 on the outside. T squared minus 12t plus 27. And now I can factorize. T minus 3, t minus 9. And that's, the question is, when does that equal 0? So it's either when t equals 3 or t equals 9. Do you give both answers? Just, yeah, if you read the question, it says, when does the ball first reach that height? So, and just check on your graph that makes sense. Yeah, when t is 3, you do get 81. Actually, my graph isn't that good. I get 71. Anyway. Okay, and that's the end up to there.